Hello everyone, and I'm very happy to be here in Sofia. I'm Marton and basically I'm a really old guy in the OpenStack community. I'm almost doing it since the early days. So when Rackspace and NASA started the OpenStack story, I joined on that August. So I saw a very little announcement in Ubuntu Planet blog post that something started that will solve the open source cloud problem of the world. And those times I was working at Telenor. I was a CTO of a Telenor company, and we were building up mobile messaging solutions in Central Europe, and we had a branch office in Pakistan. And we operated a very diverse and very different type of servers and applications. And basically, when I first time checked out the source code of OpenStack and I heard it came from NASA, and I was looking into the source code, I was realized that I never ever wanted to travel with the spaceship. So it was so bad and so crappy that I think, oh my gosh, it won't work. But from the other side, when I looked the inside architecture of OpenStack, it was very similar to those enterprise applications we were doing for the telecommunication sector, and those applications must run for 24/7 because the SMS messages must be delivered 24/7. So basically I joined to the community and started to follow the project. I was elected to an OpenStack ambassador. We are, as ambassador, starting to build up the community, and I'm one of the 3 ambassadors of Europe now. And I'm one of the co-organizers of the OpenStack Central European Day. So we are doing a 1-day full OpenStack event, and we are trying to bring in the spirit of the large summits into Europe. So usually it is much cheaper to travel to Budapest from here than travel to Tokyo or Vancouver or anywhere else in the world. And anyway, I'm the founder of the OpenStack user group in Budapest, so we have a very similar group there, and we are doing very frequent events. So if sometimes you are coming to Budapest and you have some time, let's visit us and try to participate. And among that, I have a developer background, and I'm a contributor to the infrastructure project. I'm a contributor to the community portal, and I'm working on this OpenStack ID authentication project. So I have a lot of hands-on experience, how things are going inside the OpenStack infrastructure, how we are managing the project, and maybe how to run the OpenStack in very large-scale environments. So what I like to tell you in this presentation, a little bit a different aspect that we saw in the previous one, because that was about how to deploy OpenStack. But in this presentation, I like to show you how to use OpenStack as an end user. So I tried to show a very simple web service as a use case, where we have a load balancer in the front, we have 2 application servers, and at the end we have a MySQL database. It is a very typical web application architecture. And a quick survey around here: who is a developer in this room? Great. And who is a system administrator or DevOps? Okay, much better. And who is a product manager or an architect? Okay, great. So I think most of the sysadmins are very familiar with this application architecture, and my experience that a cloud is a very nice technology, but it performs very well if you are using cloud optimized applications there. So basically, it is very easy to build up such a service manually using an OpenStack cloud service. But we can split the deployment into 2 major steps. The first step is we need to build the infrastructure first. What it means, we need to launch the servers required for the service. We need to attach any block devices or block storage if required. We need to set up the proper networking. We need to allocate and associate the public floating IP addresses. So it is very, very similar that we used to do in the last 10 years when we pick up a huge brand server and put in the rack and started to set up the operating system and plug in the network cable and start deploy the applications. And the second step is usually we need to set up an application stack. So it means if we have a server that is running and properly configured, we need to set up the application and configure the different settings of this app. So what we need for that? First of all, we need to get an OpenStack cloud access somehow. It can be basically a public cloud service, maybe from Rackspace or HP or anyone else who is providing that, or it can be a private cloud deployment. Basically, you can find all of the public cloud providers in the internet. So if you don't have any experience with OpenStack yet, it is the most straightforward step to start with a public cloud provider. Maybe you need just a simple credit card, and from $20 or something, you can start very, very quickly. It is very, very useful to check the trial and free periods or free offers all of the public providers. If you have a little bit more time or more money, you can play with a private cloud deployment, or if your company has a private cloud deployed inside, you can also find all of the OpenStack distributions available on the OpenStack website. Or if you have just a single notebook or something, you can start with a very simple DevStack installation, maybe in a VirtualBox or somewhere else. So this is the first step. You need to get an access to an OpenStack cloud service. Okay, and if you like to deploy your application, OpenStack means freedom. So you have several options there. The first option that you can do everything manually. And I usually started to suggest to start with a manual setup if you don't have any experience, because with a manual setup process, you can learn everything. You can learn the terminology, and you can learn the processes, how to launch a server, how to assign a floating IP. If you are done with that, you can choose an automatized version. Maybe I suggest to use heat templates and combine it maybe with Puppet or any other configuration management system. You can even use Ansible or Chef or anything else. Or you have the full Ansible option that you can use Ansible for even for provisioning the infrastructure part and even provisioning the application stacks using the playbooks. And you can use Cloud Foundry. Who heard about this Cloud Foundry project in this room? Yeah, so not much. Cloud Foundry basically is a platform as a service solution, and all of the governance and development model is very, very similar to the entire OpenStack project, and some guys moved to the Cloud Foundry from different OpenStack projects. So it provides a platform to launch and operate applications in the cloud. Okay, so the manual setup is a very nice way, but it is very error prone because we have a human factor. So I not suggest to use it in a production environment. But for playing with OpenStack, it is really the first step that you need to go. So basically, we have these heat templates. Heat is a templating engine, and we can use it for defining different OpenStack resources and describing the entire OpenStack architecture. And at the end, we can use any configuration management system to deploy the application stack. If you like to use Heat, the very straightforward step is to start it with DevStack. And if you are you like to use it with a public cloud provider, the bad news that not every public provider adopted heat. So maybe, as I know, Rackspace providing some heat templates, but I cannot find it in production for HP public cloud yet. So this can be a real limitation, and at the public provider you don't have too much influence how to set up and configure heat. And the Puppet for provisioning is a mature enough solution, so you can use Puppet as you are using it in every other environment. And basically, it is very, very easy to start with heat. So if you have maybe a DevStack deployment with heat, you just need to create maybe a simple YAML file, very similar to Ansible. You can describe the different resources, and you can describe in a different YAML file the very class-specific things, like maybe the networking IDs for your cloud, or the different class-specific things. And if you are ready with that, it is very easy. It is just a single command. You need to start this heat stack create and specify these two YAML files, and it will automatically start deploy this cloud. I will try to show you an example of this quickly. Side. Yeah, can you see it anyway? So it is a very, very simple YAML file. You can simply define the public network ID of your cloud as a parameter, or the private net ID, or the private subnet ID. And you can define very simple resources, for example, as a server. And you can set up the core image that you like to use to launch this server, the flavor of the server. Maybe you like to start a small one or a large one. And I guess the networking part is the most complex one in the entire OpenStack. But you can define a server port, and at later you can associate floating IP to that server port and assign this to the server, so you can access it from the external network. The tricky part that helps a lot to launch the Puppet Puppet part of this deployment, that you can define a so-called user data. This user data can be maybe a bash script or something else that will be launched after your server get launched in OpenStack. So basically, if you can launch a bash script, you can do anything. So basically, you can set the host name of the server. Maybe here I'm setting up the name servers for this deployment, because sometimes the default settings are not so good, and I can deploy the core packages I required. And I'm basically doing the trick here that I'm cloning out a Puppet repository from GitHub, and I'm simply deploying the required Puppet packages and using a Puppet apply to orchestrate all of the application stacks I required for that server. So basically, it is a very automatic thing, and when you, at the end of the day, you will get a really working application stack with a simple heat create command. So maybe after the presentation I can show you a demo about this, because it is working in one of my pilot environment. So basically the takeaways for the heat, it is very important to set the hostname, the DNS servers, and maybe update the packages for your Ubuntu image, or you can prepare your own images and use that, and you can speed up the entire deployment process. After that, you can check out the Puppet repository, install the required Puppet and modules, and finally doing a Puppet apply. If you are building up a more complex environment with Puppet, I suggest to use a Puppet master and register your new nodes into that Puppet master, and all of the Puppet code will live in Puppet master, and you do not need to use this Puppet apply methodology. So this is the one way, this heat template and Puppet. The other one is Ansible, and I like to focus mostly in the infrastructure or resource orchestration, because Ansible is the new hype, I guess, next to the containers and software-defined networkings. And it is still in move, or we experience a very heavy development there. So this specific use case is a little bit different than we saw in the previous presentation, because we are launching servers using Ansible. So to do that, we require some extra patches for the core Ansible OpenStack module, and we have a very nice list of that. So it requires some preparation from our side, or others. So maybe this is the list of the required patches in GitHub that is waiting for an approval. So maybe if you need some specific networking thing, it is useful to check whether you have a specific patch available and make your custom Ansible release or module release for that. But I guess it will very quickly change, and maybe within 2 or 3 months everything will be in the upstream and stable Ansible. So the OpenStack community is really working on that. Okay, so the hard part is this neutron or floating IP part that is under refactoring now. And we, of course, need some additional dependencies to deploy. We need this shade library. It is a brand new component from the OpenStack infrastructure team. Maybe if someone saw the presentation from Monty Taylor in Vancouver, or if you cannot attend, you can watch the video recording about that. It is very interesting because this shade module tries to hide all of the differences of different cloud providers. Maybe a very simple thing, because maybe 2 public cloud providers defining the flowers in a very different way, and shade trying to hide those differences. And it is also using this OpenStack client config module that helps us to define all of the OpenStack credentials required for deployment. And this is the infrastructure part, so we can use Ansible for deployment and set up the servers and assign the network and floating IPs in a proper way to architecture. For the application stack setup, I don't like to talk about too much. Basically, it is stable enough, and you can use it very similar ways as every other playbooks. Okay, and the third way is the Cloud Foundry. So basically, it is an open source platform as a service solution. It is very easy to deploy into an OpenStack cloud. It has the very same REST API we are using for OpenStack. And instead of defining YAML files, it is using a so-called build pack. So a lot of predefined build pack environments available for different platforms. So if you like to orchestrate a PHP application or a .NET one or a Java, you can find an existing build pack. So if you have very specific needs, you have the freedom to customize those build packs. So it is very easy to start with that. maybe it is my personal experience that, for example, I use this HP development stack that was based in Cloud Foundry, and starting from zero to a running application took maybe 20 minutes. So it is very easy to learn and very easy to start to use. Maybe using it in a production environment is a different question, but it is a very, very nice story. And it is very easy to deploy a new application. It has a built-in auto-scaling feature. For example, if you like to use auto-scaling with heat, you need to do all of the integration with cellometer and the telemetry system. So it requires a lot of engineering hours if you like to deploy it in your own private cloud environment. And basically, this Cloud Foundry story is focusing on application deployment and no much infra magic required. So a very simple use case for this Hello World application. It is very easy. You are simply creating maybe a one-line PHP application, and if you have a deployed Cloud Foundry solution in your cloud, you need to give out just these 3 commands. So you need to tell what is the target of your Cloud Foundry API, you need to log in with your credentials, and you need to push up your application into Cloud Foundry. And after that, you can experience that you have a working PHP application in the cloud. So it is very well integrated with OpenStack. So to summarize everything, you can use a lot of different tools to deploy end-user applications into the cloud. So maybe you need some orchestration tool that can help to set up the infrastructure part. You can use Ansible, Heat, or Cloud Foundry for that. Maybe you need to define some infrastructure description in a YAML file or maybe in a build pack. And after that, you need to do the configuration management, where you can describe the application stack in some form, maybe as a Puppet manifest or an Ansible playbook or something else. And at the end of the day, you will get a running application. So it is very easy. Okay, and some marketing at the end. The next OpenStack Summit will be in Tokyo. And who contributed anything to the OpenStack? Okay, 1 guy, 2, 3. Oh, that's very nice. So if you are contributing back to OpenStack, you will be a so-called active technical contributor. And if you are an ATC, you have the right to participate in the travel support program. So if you apply into the travel support program, you can get a free trip to the Tokyo Summit. The foundation should buy your flight ticket or the hotel room for the event, and you can get a free ticket for the event. So if you have some intention to start the contribution, I suggest to do it early. Maybe if not for Tokyo, the next one will be in Austin after Tokyo, and after Austin, the European one will be in Barcelona, Spain. And if you like to learn about how to contribute to OpenStack, we have so-called upstream trainings. And it is a community-organized trainings to introduce all of the tricks and best practices of contribution. And usually it used to happen before the summit, in maybe the weekend before the summit. So I guess last time in Vancouver, as I remember, around 50 or 60 people participated. And most of them get a contribution at the end of the day. So it can help you to get some ATC level and maybe a travel support option. Okay, any questions at the end? So was that useful or new information? Or everybody know all of the details and tricks of application deployment? Okay, guys. So I will be around here. So if you have questions about OpenStack or the OpenStack community all around in Europe, I'm happy to answer the questions. Thank you.